So let's suppose that we want one thing to happen if our condition in an if statement is true, and another thing to happen if that condition is false. And we can look at a flow chart. It looks sort of like this, where we've got our conditional. If the conditional is true, we do a bit of output. And if it's false, we do nothing. And then in either case, when they meet at this junction, everything continues on to the, doing whatever more stuff might be. Closing out the program or sharing more number facts. So if our condition is true, we do the true branch, the yes branch, so x is divisible by 7, do some output, then swoop down and we do whatever's after our else block. And if it's false, right now we do nothing, and then we go down and do whatever's after the rest of it. And so these are the bits that we have. So there's got to be, and there is, in fact, using the else statement, a way to make it so that we can do things if a condition is false. And so when that happens, again, we use the else statement. And it looks sort of like this. So we've got some condition, and if that condition is true, we do some stuff, and then we do more stuff. And if the condition is false, remember how when it's false, our program flow jumps down to the end of this block, and if it immediately finds an else, we do the thing in the else. Otherwise, we do whatever's next. So if the condition is false, we do some other stuff. That's what it ultimately boils down to. So here's when our condition is true, when our condition is false. Now the old way, and this way doesn't work for very long. We have if our number is divisible by 2, let's say, if its remainder when divided by 2 is equal to 0, then we can print out, the number is even. And then if our number divided by 2 is not 0, we can print out, our number is odd. This is the old way, and it's not it's not horrible, but it's not great. And the big reason that it's not great, I guess the two big reasons. The first reason is that as we go down, so if this if statement if it doesn't evaluate to true, we skip down to the end and then we evaluate this one, and we know from looking at it that one of these has to be true, since there's no way that a number can be, there's no way that an integer, I guess, can be neither even nor odd. No such integer exists. But when you have more complicated conditions, as we will, like we're definitely going to have more complicated conditions, it becomes harder to figure out how to write the exact opposite of everything. And it's really easy to make mistakes there, especially when we have really complicated multi-part conditions. That becomes a lot harder for us to take care of. And so this is the old way. The new way, which is a lot simpler, is if our number divided by 2 is 0, that is to say if it's even, we print out that it's even. And if it's not, if anything about this is false for whatever reason, we print out, it's odd. Which is to say that at this point, and the benefit that this approach has over the previous approach is twofold. One, we guarantee, using this if-else statement, that one of these will happen. We guarantee it. Like there's no way for this condition to evaluate as neither true nor false, unless it somehow crashes our program, in which case nothing happens. But otherwise, this condition will evaluate to either true or false. Whereas this way, we can't necessarily guarantee that our condition is either going to be true, that one of these is going to happen. The other thing that's a benefit is that if this is true, once we get down to the end, we see this else block and skip down to the end of the else block. Which is to say that if this condition is true, we do this line, hit this closing curly brace, and then immediately jump down. And if it's false, we skip over this, do the stuff in here, and then immediately jump down. In this one, we have to check if our number is divisible by 2, and then we have to check if it's not divisible by 2. In both cases, we can jump down. So we're not able to skip the evaluations. We have to do 2 evaluations with this method, whereas using that method, we only have to do 1. So that's the benefit of the if-else block. And generally, if you have a situation where a decision has to be made, if you have a decision where you know for a fact that either something will happen or something else will happen, depending on how a condition is fulfilled, you should be using an if-else block, particularly if you have a related decision. And there's a couple of things for us to remember in terms of best practices. Every else absolutely has to have a corresponding if. You can't have a wild else just kind of roaming in the middle of your program. You can only have one explicit else statement per if, which is to say that we can't have if, else, and then another else. Though we can do if, else, if, else, if, else, if, and then another else. And then finally, or I guess not quite finally, not every if needs an else. That is to say that you can have an if statement that doesn't have an else, but it's generally good practice to put one there. Even if you know that the if statement isn't going to execute, it's generally good practice to put an else statement if you can, as that'll help catch errors. And then finally, there should be nothing between your if block and the corresponding else. And this is called a dangling else, and I'll show you what that looks like here in just a second. And so here's our initial flowchart. You'll remember this from the if-else statements, where we've got, this is our if block, that diamond. If it's true, and then we move on. And when we add the else in, we just add another box in here, right? So this is if our condition is true, and here's our else branch. So when our condition is true, if x is divisible by 7 in this case, we output x is divisible by 7, and then we go on and move down to the end. We skip over everything in the else block. And when our condition is false, we skip over everything in the true block, output x is not divisible by 7, and then we go on and we do more stuff. And so in either case, like the green represents one path, the red represents the other path, and the blue part represents like what's going to happen inevitably. And we can see this is how if-else blocks are supposed to work, where you have a branch, one thing can happen or another thing can happen, and that is the extent of how our program works. Now, one problem that you might run into is a problem called the dangling else, right? And the dangling else is a problem that's created when we have something between our if statements block and its corresponding else. In this case, we have the system.println some text. Okay, so when we look at this, we're going to see, or when we compile this, we're going to see an error on this particular line. And we're going to see an error actually on the following line, which is going to be an else without an if. And the reason is because we have this line between the closing of our if block and the start of our else statement. We can't have anything there. That's going to keep our program from compiling. And the error that we're going to see is that else without an if. And most of the time, when you can fix these errors pretty easily by using curly braces correctly, and by making sure that there's nothing between the closing curly brace of your if statement and the start of your else statement. So let's take a look at this in the wild, as it were. And so we've got this dangling else demo, which I'll show you real fast. It's going to look almost exactly like we had before. So we're going to make a scanner, do some output, get some input, check to see if our number is divisible by 2, then do some output, and then we have the else. So this line 17, is the line that's going to be the problem. So on line 18, what we're going to get is an error that says else without an if. Okay, so let's save and quit. We'll compile. On line 18, we get this error, else without if. And the way to fix this, that particular line, is just to get rid of this one. And instead of getting rid of it completely, we're just going to comment it out. And by commenting it out, what we're doing is we're telling the compiler to ignore it. We're telling the compiler, hey, skip over this. It's not anything that you need to worry about. The compiler automatically ignores all comments. We can save and quit. We can try compiling again. And this time, okay, we have, here's our problem. An incorrectly named variable. And we know that, so we know we have an incorrect, so it's the error cannot find symbol on line 14. And then the way that I knew how to solve that was up here we had a variable called x, and down here it was called num. Okay, so the problem that we ran into was we were trying to use a variable that didn't exist. Okay, so we've got that set. We'll try compiling again. Everything works, and we can run it. And if you give it a number, like say 15, we get it's odd, And if we give a number like, say, 18, we see that it's even. And this all comes back to knowing that we have an else right after the closing of our if block. And it doesn't really matter if there are comments between. Comments are completely and totally ignored by the compiler. They don't do anything other than tell the programmers kind of some notes. But it doesn't particularly matter that that exists. This is a problem that you'll have to watch for. And the way that you'll see it is you'll see that else without an if error message when you try to compile. And it won't be too bad. Okay, so if we head back to our slides, the next thing that we're going to talk about is the ability to do multiple things with a single if-else block, or with a single if-else block. And the way that we're going to do that is by combining those into what we call the else-if statements. That's where we'll be when we come back. See you in a bit.